ladies and gentlemen.
Let's talk solving rational expressions. So just like we can simplify fractions when we have common factors, like 12/16 is the exact same as 3/4 if we divide the 12 by 4 and divide the 16 by 4, we can get to 3/4. Or we can also rethink our thinking to 12 is 3 times 4, 16 is 4 times 4, and we can cancel out these common factors of 4. Both ways of thinking work, but this different way of thinking, this one on the left here, will help us out tremendously when we have algebra involved in our rational expressions. So just like what we had before, we're going to try to factor this out, write this as factorized as we can, and see if we have anything that can cancel. So in the numerator here, I notice that the 4x and the 20 both have a common factor of 4. So I'm going to write this as 4, and then x plus 5. And the denominator is the difference of squares. X squared is a square, 25 is a square, so this factors into x plus 5 times x minus 5. Well, look here, they have a common factor of x plus 5 in the numerator and denominator, so we can cancel it out from both, leaving us with 4 over x minus 5. So not too bad. That's the basis of what we're doing. When we multiply, just like we would multiply fractions, we multiply straight across, but I can make my life a little bit easier by simplifying beforehand. So I notice that both this polynomial and this polynomial are both factorable. So if I factorize the numerator, factors of 6 that add to -5 would be -3 and -2. And then I can keep the y squared the same. Over here, I'm going to keep the y, not equals, we're multiplying, Mr. Whaley. And then I can factor out a 4, so that would be x minus 3. I notice that I have a common factor of x minus 3 in both. I can cancel one out from the numerator, one out from the denominator, and that's perfectly fine. I also have 2 y's in the bottom, 1 y in the top, 2 y's in the denominator, 1 y in the numerator. Mr. Really needs to use better language. We can cancel out 1 y in the numerator with 1 y in the denominator. So we're going to get rid of that squared and just replace that with a y. Now we can multiply across. So we would have x minus 2 over 4y. And that would be simplified. Division is a little bit different. So if I were to ask you, hey, let's do 3/4 and let's divide that by 1/2, you would know to multiply by the reciprocal. You would change the question to ask instead 3/4 times 2/1 and go about it that way. We're going to do the exact same thing with our rational expressions here. If I have division with fractions, I need to multiply by the reciprocal. So I'm going to start by rewriting the problem. So we have 9x squared minus 1 over 6x plus 2 times 2 over 3x minus 1. Now I'm going to try to factor as much as possible. So I notice I have the difference of squares here. 9x squared is a square and 1 is a square. So I have 3x plus 1 times 3x minus 1 in the numerator. This is also factorable. This has a common factor of 2. So 2, and then I have x plus 1, or 3x plus 1, my bad, times 2 over 3x minus 1. And now we're going to try to cancel out all of the common factors we have in the numerator and denominator. I have a 3x plus 1 and a 3x plus 1. I have a 3x minus 1 and 3x minus 1. And I have a 2 and a 2. Everything canceled. What's left? Is it 0? No. Because we canceled everything out through division and multiplication, everything would cancel out to 1. If we were canceling things out through addition and subtraction, we would end up with 0 instead. All right. So what if we have addition and subtraction? We need to have common denominators. So the only way we can add or subtract fractions like 3/2 and 5/4 is if we have the same denominator. I would have to multiply this fraction top and bottom by the same value so that the denominator becomes 4, which in this case would be 2. It is the exact same if I have algebra. I need to multiply numerator and denominator by the missing factor. So the least common denominator is all of the unique factors from both denominators multiplied together. So if I look at the first denominator, I have 3 times x minus 5. And the second denominator, I have 5 times x plus 5. There are no common factors. Every factor is unique. So instead of using the factorized versions, I'm going to multiply the fraction that does not have the 3x minus 15, the right fraction, by 3x minus 15 on the numerator and denominator. Likewise, on the fraction on the left, I'm going to multiply it, numerator and denominator, by the 5x plus 25. And that should end up with the same denominators for both fractions. Let's do that, shall we? So this first fraction here, I'll write it in white so it's consistent. X minus 1 over 3x minus 15. We're going to multiply this top and bottom by the factor it's missing. This 5x plus 25, 5x plus 25, and we're going to multiply. Now, the denominator is going to be nice, I guess. It will be 5x plus 25 times 3x minus 15. We can distribute that, but I'm going to leave that as is for now in the off chance that something cancels out later. So this is going to be the common denominator for our fractions. Likewise, I'm going to rewrite this fraction here in white. And I'm going to multiply this one, numerator and denominator, by its missing factor, which would be the 3x minus 15. So multiply 3x minus 15, 3x minus 15. Now we get to distribute. So hopefully you've been practicing your distribution skills. I'm going to cut up each one, and that will help me distribute. I kind of really wrote over that. All right. So 5x times x is 5x squared. 5x times negative 1 is negative 5x. 25 times x is a positive 25x. And then 25 times negative 1 is negative 25. And then we are subtracting x times 3x, which is 3x squared. X times negative 15, which is negative 15x. 3 times 3x, which would be a positive 9x. And then 3 times negative 15, which would be a negative 45. And all of this has that common denominator of 5x plus 25, 3x minus 15. Well, just like we did before, we need to distribute the negative. So plus, minus, plus, minus, plus, and we can combine our like terms. So we have 5x squared plus negative 3x squared, which gives us a 2x squared. Now we have a lot of terms with x. We have this negative 5x, positive 25x, positive 15x, and minus 9x. So if I combine my positives, I have 25 plus 15, which gives me 40. And then negative 5 and negative 9 is a minus 14. So that gives me 26. So I'm going to have a positive 26x. And then I have a negative 25 plus a positive 45, which gives me a positive 20 for my numerator. My denominator will stay the same as a 5x plus 25 and a 3x minus 15. Now I can try to simplify this a little bit further. I can factor out the greatest common factor of 2 from the numerator, leaving me with x squared plus 13x plus 10 over, and I can factor out the 5 and factor out the 3, giving me a 15 times x plus 5 times x minus 3. Now, this quadratic is not factorable, meaning that its solutions are either imaginary or irrational, and I can tell that because there's no factors of 10 that would sum to 13. So this is as simple as it gets. The last one. Now, this one, I wouldn't be surprised you would just pause the video and throw it away at this point. This type of problem can be difficult. In fact, it's a type of problem my calculus students struggle with immensely. But don't let that deter you. It's 100% algebra. It is 100% something you can do. So let's do it together. The first thing that we're going to focus on is we are going to ignore this here. We're going to ignore the 1 and the division symbol in the numerator. We're just going to completely put that off to the side. What we are going to do is we're going to focus on the denominator, which is 1 over x minus 2 plus 1 over x plus 1. And we can simplify this very similarly to how we did it before. We're going to multiply numerator and denominator by the missing factor, so x plus 1 over x plus 1, x minus 2 over x minus 2, which gives us, if we distribute the 1s, x plus 1 plus x minus 2 over x plus 1, x minus 2. If we combine our like terms here, we end up with 2x minus 1 over x plus 1, x minus 2. And now we can actually go back to the division. So technically speaking, this is all a denominator. So we have 1 divided by this fraction, 2x minus 1. And I'm going to distribute this because there's nothing that's going to cancel out, so there's no harm in that. And that would be x squared minus x minus 2. When I divide something like 1 by a fraction, what do? I multiply by the reciprocal. So this is the exact same as 1 times x squared minus x minus 2 over 2x minus 1, which gives us x squared minus x minus 2 over 2x minus 1. There's no simplification that we can do from there, so that is our final answer. This may seem scary. Fractions seem very scary to people, but you have to approach it methodically. You can do fractions. Everyone can do fractions, and I, for one, have faith in you. So, if you have any questions, let me know. Otherwise, I'll see you in the next video.